So at this point, there's really only a few more things we need to add before we have all the basic core mechanics of Lumines implemented in our project. So one thing we obviously need to add is the timer bar that sweeps from left to right. You could call it the sweeping bar or the clearing bar or the highlight bar. I'm going to call it the timer bar, even though it's not really a timer. It acts as the timing restriction for the player to rack up a combo. They need to be quick enough for the bar before it passes through. So like the combo system in Lumines, if you match I think at least 3 blocks, a total of 12 individual tiles, if you match at least 3 blocks every time the timer bar sweeps across, that increments your combo counter up to like 4 or 5x, which gives you more points per match. And if you go one cycle of the timer bar without 3 blocks being cleared, then or 3 matches being cleared, then your combo gets reset. So we can go ahead and implement that. I mean, that's pretty simple. We won't worry about 100% emulating perfectly the scoring system of Lumines, but get the general gist of it. Should be relatively simple. So once we get the timer bar, we have the bar highlighting matched tiles as it passes through them, and then we have them being cleared and destroyed when the timer bar gets to the right hand side. Then we need the gaps left over by the cleared blocks to be filled by the blocks above them, so that will involve dropping every single block down all the way. And there's a few ways we can handle that, but that'll be one of our last big logic puzzles to solve before we have the project completed. So we'll go ahead and start with making a timer bar actor, and so that does mean I should probably make a new C++ class for the timer bar actor. If you don't like the name timer bar, feel free to call it whatever else makes more sense to you. Okay, now we have the C++ class, and hello, Visual Studio. Go ahead and make the child class in Blueprints. Now, very exciting, but I think I'm going to make this a cube. So let's go ahead and add a static mesh component. I'm going to go ahead and not make this the root, just in case we have issues with scaling again, like we had with the block, where we needed to make the new root component and then add the mesh as a child. So we'll go ahead and keep it like this. I'll just call it a timer bar mesh, it doesn't matter. Add our cube. Oh, look at that. That's handy. I guess after resetting the engine, those 2 other engine folders are hidden again, which is convenient for me. I'm not having to worry about all those meshes here. So now let's go ahead and stretch this thing, I suppose. We can consult some videos of the real Lumines game to see, how thick this bar is, or how what color it is, and how shiny it is. Okay, I just had a quick look. It's a fairly prominent but thin orange line that has a trail. It leaves like a trail of light behind it that fades away, so it's really always easy to tell where it is. And it has a number on the top, like a UI element that shows you how many matches you've made on the current cycle of the timer bar. So we can go ahead and add that too, so that leaves it clear for the player so they know how close they are to getting 3 matches in that turn or whatever. I'm going to shrink it down in the y-axis. I should probably do the same thing with the blocks too, but whatever. And we'll go ahead and make a new material, even though it will be similar to the block color 0 right now, but we'll go ahead and make a separate one because we don't want it to be reliant on the block colors. Call it a TimerBar mat. We could even make this like a transparent, translucent material so that it's sort of see-through with an opacity. That could be kind of cool. Gonna hold the V key and left click for a parameter and call it orangish, light yellow maybe, dark yellow. Multiply this by a emissive strength color, parameter. So gonna right click this, convert to parameter, call it emissive strength. And we'll set the opacity to maybe like a 0.8 or something, just to try out what that looks like. Or maybe even lower than that, so it's semi-see-through. And again, I don't know how the emissive colors affect the opacity. It might make it look translucent, look opaque even at low values. I mean, here you can see through, you can see the background material there, the skybox a little bit through the material. But yeah, that's interesting. We'll just leave that for now. We can tweak it later. I see that I capitalized the I in timer. I'm going to fix that right now. Then we'll add the material. Now, for the movement of the timer bar, we obviously want it to start at the grid's root location, and then, start here and move to the right, get to the end of the grid, and then reset on the left-hand side. I'm going to briefly consult the Lumines gameplay videos again to see where it ends and how soon before it restarts on the left-hand side. If it's immediate or if it's got like, a quarter of a second of lag time. Okay, from what I can tell, it appears to be directly on the edges that it starts and stops, so it spawns directly on the left edge. And as soon as it gets to the right edge, it immediately respawns on the left-hand side. Nice and simple. And we'll go ahead and do that now. So we will get a reference to the grid by just, this is probably bad form to do this, but I do this sometimes when I don't think performance is any sort of issue. Now, this is probably not the best way to do it, because we might run into a race condition where if the game mode doesn't spawn in the grid before, but that's a race condition, we're just asking for trouble. So we can just have the game mode give the grid reference to the timer bar. So we'll just have the game mode have references to everything. This is just a safer way to do it. So we'll get the grid reference. And you know what? This is the optimal way to do this, is to have the game mode spawn in the timer bar in the first place. So obviously when it spawns it in, it can send it the reference to the grid. Or we'll know for sure that the timer bar is spawned after the game mode, so that we can run that for loop anyway. But that's not the best way to do it. We should just pass it directly. We can even do this. Give this timer bar a grid reference 2 and expose it on spawn and just plop it right in there immediately. So we'll have a grid BP reference, and this will be exposed on spawn, which, you know, not necessary to do it this way, but we can, so we will. And it's just showing a different way to pass things. There's so many ways to get data from one blueprint to another. So we'll just spawn in another actor. This time it will be the timer bar. And we can just pass this grid reference directly in. So we don't even need to keep it as a parameter here if we don't need to, but let's just get rid of it for now. I'm sure we'll probably need it at some point, but for now we don't. So the grid that we just constructed will get passed to the timer bar. And the location for this guy should be, you know, the same location as all the column cubes in the grid. So the location for to spawn in the timer bar is going to be just like with the grid location for the column cubes. We want the z-axis component to be, you know, offset halfway up the grid like this. So we can just copy and paste this in to the game mode, since it has its own vertical offset and num rows. And we'll split this pin. Here's the z component, and the x and y components are 0 for the initial location. You know, we should probably actually do something like a parameter here. Call it timer bar starting location. Make this a vector. And set it to this. We can set this on like construction. So before we begin play, before we do any of those events in the event graph, we'll set timer bar starting location to this value here. So now we have the starting location. That's all we need. We don't need the end location. That's determined by the collision. So here we have the starting location, which will just feed into the location here. And the reason why I want a parameter is because we're going to reset the timer bar to that location, this location, whenever we collide with the box on the right hand side. So I suppose we can just do on tick, a tick based movement system, which I think that's pretty common. So we'll just have a new execution pin come out from tick, and we'll say set actor location, get actor location, now the timer bar is only ever going to move left to right, so we don't need to split the pins as we always have been doing. I'm just going to do vector plus vector, and we can make a speed value here. Call it just speed or horizontal velocity if we want to be more accurate. Turn into a vector, and just I don't know what's going to be good, so I'm just going to put 200 for now and change it later. Now obviously that's not, we don't want to move it 200 units every single tick. That's not what we want. We want to move it, that's the velocity in terms of, you know, units per second, but we want to have the delta seconds determine how much we move this tick. So we'll do this value times the delta seconds. And this keeps, frame rate independence so that the velocity is constant in real time, or, almost, basically real time compared to how many frames are getting output per second or whatever. So we get our current location, add horizontal. This is not correct either. We want to add horizontal velocity times delta seconds to our current location. This is going to give us something we don't want. Horizontal velocity times delta seconds gives us the fraction of the horizontal velocity that we actually want to add to our current location to get our new offset, our new position rather. So let's just see if that works. There we've got our bar moving across, and it's a little slow, but that's fine for now, I think. Now I need to have it collide with this box. And it's also a little bit too big, isn't it? One more time I will consult the gameplay videos to see how tall it should be and how much thinner it should be. So as you might expect, the timer bar is exactly as long as the column cubes are, which I believe we scaled it to times 10, so we will do the same for the cube here. But that doesn't look correct. If we scale this to times 10, I think it's going to be too short. Probably because the way we're scaling it is different. Also, it is not offset the correct amount. That would explain why it's too short. So, let's look at what we're doing here. We're not offsetting it properly. When we spawn in the timer bar, we're using timer bar starting location, which we initialize in the construction script to 0, 0, and then this should be 500 since numRows is 10. This is 5, so times 5, 500, and the Z offset from the origin. We will use the print string to see what's going on here. Okay, so it's not being initialized to 500 as we expected, so let's check the construction script here. We are calling set timer bar starting location. Another print debug prints are always the first go-to for me. It says 500 in the construction script that runs when you make a change to a blueprint like this. Then you look over here, it says 500. So we're obviously setting the Z component of timer bar starting location to 500. Let's try setting it in the event graph instead of here in the construction script. And if it works, I'll clean this up a little bit. Okay, that's interesting. I guess there's something I didn't understand about the default values in the construction script. maybe it's being accessed too quickly after construction or something like that. I don't know. But we can go ahead and clear the prints now. I will move this. Let's just get rid of this. We don't need it right now. So that's that so far. TimerBar is moving, and now we want to have the TimerBar collide with the collision box, which it's already doing. We just need to have the overlap events actually do something. So here we'll have an on overlap begin, actor begin overlap. If the other actor is grid, which it will be if it's the collision boxes on the grid are the only things that have overlap events firing. Now we have to make sure it's not the left-hand side of the grid, so we'll do that with another check if we need to. I think a good way to be self-documenting and unambiguous when we are talking about which collision box we're overlapping is to just explicitly define the right-hand collision box. So this will be the one on the right-hand side of the whole grid, right? Yeah. So we can define this as right collision box and just make a box collision reference and set that when we add it, and now the grid has a reference to that specific box. We can do the same for the other boxes if we ever needed to, but for now we'll just have that one. And now when we overlap, we say it might be better to do a on component begin overlap instead of on actor begin overlap, since we only have one overlapping component anyway, and this way we can get access to a few more useful nodes right off the bat. So if we say on component begin overlap for the TimerBar mesh specifically, then we get the overlapped component, and with that we can more quickly say, if this is equal to the grid's right collision box, then we can print overlapped, end box, and then we'll know that it only is going to fire this event for the or fire this action when it's the right hand box that we overlap. Let's see if that works. So it didn't work. Let's see what this comes out as being if we print string here. Oh, I'm foolish here. This should be other component, the thing we overlapped with on the other actor that we are overlapping with, not our own component. Okay, we do get overlapped end box, so that does work. So we don't even need this at all, I don't think, for now. The point of all this was to accomplish a way to reset our location when we overlap the right-hand collision box. So when that's what we overlap with, we're going to... First we should probably shrink our size down a little bit more. That was something I needed to do earlier. Let's say 0.2, just for now. And when we overlap that right-hand box, we want to reset our location to the starting position that we set up in the game mode. I've done this like a dozen times by now, so hopefully you understand what I'm doing, just setting up a reference to the game mode. Here we get game mode and get TimerBar starting location and set actor location to this value. And this eliminates any need to, pull our location in a tick, say like, we've set our location to our new location, now check to see if it's past just endpoint and then reset. This should hopefully be more efficient because it's only happening on an overlap, which it will overlap other things too. And so when we have to start, highlighting blocks, which we're going to do in a few minutes, we will expand this logic to handle the other types of collisions too. But now it should get to the right hand side of the grid approximately, and then reset on the left hand side and keep moving. And we can work out the fine details here if we want to see if it gets close enough to the end here before it resets. We want it to basically just touch the right hand side and then reset. So it might want to go a little further, but I think that's probably fine. Seems reasonable. Now I can move on to checking for the blocks that are in play, and if they are part of a match, we will highlight them. And we can do that over time, as we did with the matched state for the blocks, so that they turn into their highlighted state over time. We'll go ahead and get started on that now. It shouldn't take all that long, and then we're getting close to having a full game.